Dr. Mark Biddis, former space scientist turned mathematician and conjurer of wacky science. His goal is to prove that science and maths can be weird and even downright fun.
Squeeze hard, good blow.
He inspires pupils' curiosity and shows teachers how to do it themselves.
Balloon skewer. Now, of course, the interesting question is what happens when you pull it out?
He's been to over 500 schools, and today he's at the Orion School in North London with a mission to put some magic back into science and maths.
Do you want to hear a scary story? Yeah! There's this school for naughty balloons. What they do, when you've been really naughty, they say, right, come out here, put your head on this machine. Then you go, right, stand still, don't muck about. I can't believe it. So, right, let's try another one. Let's try the blue one. Naughty balloon, stay here. Keep the head, be still. Definitely a bit naughty that one, blimey. Right, look at the other one. Ah, but this machine is so smart. It knows that this balloon didn't actually do it and wasn't really naughty, so it's not going to blow it up. People like magic tricks because they think, wow, how is that working? And there's this peculiar, pleasurable confusion they get. So I find science experiments and maths experiments that I could wrap up in this magical way to get the kids' attention and get them thinking. Did you do it? Stand there. Definitely did it. Very naughty balloon. Next time you decide you want to be naughty, just remember your teachers now know about this weapon that might blow you up, okay? Just be aware.
The magic show was exciting and I didn't know what was going to happen.
Listen up, everybody, you've got to do something as well. You're only good at humming. Yeah. When I say start humming, I want you to keep humming until we blow Nasir up. We blow the pot up. Okay? So up in the air. Are you ready? Start humming now. We can make maths and science creative by asking open-ended questions to the kids, like, what do you think is going on? What might it be? If I said to you, right, from the things you saw happening, would anybody like to tell me one thing that you might think might have had something to do with it? Right, so over there. Water. Right, so it could have had something to do with water. Excellent. What else?
Vibration, when we were humming.
The humming, so it could have had something to do with vibration. Excellent. So we have to think of all the things it could have been. And then we have to design experiments to test everything you just said. So I'm going to be telling your teachers how it works. Actually really simple. It's a lovely experiment, so easy to do. The secret ingredient was an Alka-Seltzer, or similar. A fizzy tablet. Had it blue tack into the lid.
Well, we hope Dr. Mark will enthuse our teachers. We already have very positive teachers, but we think that science has just taken a little bit of a back seat in primary schools at the moment, and it will just enliven teachers to think, yes, there are different ways of presenting science.
So what we're trying to do is stretch the rubber evenly in all directions. Let it all the way down. And then blow it all the way up again. This time let it down halfway. I do. And knot it. That's not bad. We'll try that one. You get your stick. And when you put a sharp stick, it doesn't pop. The next thing is going all the way through. So what we've got to do is try and get this to come out through that dark spot. I then put 3 fingers there, and I'm essentially pushing it out between my fingers. Now you might think, my gosh, that's dangerous, Dr. Mark. The secret on this is not to push hard. You must only push gently and twist gently. And you can make yourself a balloon kebab. Like that. But don't eat it because it tastes disgusting, right? What do you think would happen if I pull a stick out on this one?
Go down.
So the balloon will go down. Hands up who agrees the balloon will go down.
You managed to get it all the way out because there were 2 holes in it.
Try.
Or it could stay the same.
Or it could stay the same. Remember, we must consider all the possibilities. It could pop, it could go down, it could stay up. Should we try it? Let's see what happens. Right? Creak. And of course, you can pop it afterwards because it's a balloon, isn't it? It's going to pop.
When I went home, I tried the one with the balloons. Yeah, and it didn't pop.
This one uses a strip of paper. You turn it into a loop. Okay. And here's the tricky bit. It's actually quite easy, really. You turn it over. Now, I use my sticky tape to join it together. You can put your scissors through it. And then all you do is start cutting. And you'll come back to where you started. There it is. Right, now, how many loops we got? 2. It's interesting, you know, that this weird shape doesn't turn into 2. It gets bigger. Weird, isn't it? Hands up who thinks they could do that. Yeah, it's easy, isn't it?
Normally when I'm doing maths, I always think about numbers and I always think about times tables and all the numbers, but now I know how to think of it in a different way.
Do you remember this morning when I first done the trick? I said, how many loops are we going to have? And everybody said 2. Was because most people thought it would turn into 2 like this one does. But you've now seen that it doesn't do that. Why don't you do it? 1 turn, 2 turns, and then cut it again to see what happens. It's very difficult to actually describe in words what happens with the Mobius loop. But if you do it yourself and do it a few times, you begin to build up a conception in your mind, a visual picture, and that's what I'm trying to get them to do. So it's a visual puzzle which they can only really see the solution to in their mind. 2 joined together. So that's different from what you did earlier, isn't it? This is a bendy milkshake straw. You stand very still, hold the balloon in the air, watch carefully. Okay, I know when some of you do it for the first time, you're going to start dancing about. You're going to go, how are we doing? Stand, try and keep still. And remember what to do.
Nice one, Aaron.
And once you've done it with 1 balloon, try a different size. And then I'm going to put that one on. Topics which teachers often like help with are things like forces of motion. So I come up with activities which they can use to demonstrate forces of motion and get the kids thinking about forces of motion in this fun and engaging way. I'll tell you a little tip on this one. If you give it a gentle flip, watch what happens. With the flipping fish, the science is actually very complex. What we're not interested in is the science. What we're interested in is an experimental procedure, the process. And I want to see if they'll notice it. If they change the design, sometimes it spins more quickly, and the ones that spin more quickly take longer to get down. It's a very neat experiment. I'm going to make 2 cuts. 1, 2. There are 2 points. Now, what we're going to do, I'm going to squash them together. Good blow. To try and show the kids that science and maths is going on around us in everyday life, I deliberately use activities where I've got things like bottles, balloons, pencils, straws, bits of paper, because I know then they will see those things and be engaged by them because they know they have them at home themselves. A little safety tip, if you do it that way, you might accidentally cut your nose off, right? So be aware. Or get it stuck up your nose. These ideas in science and maths can be used in a variety of ways. So, for example, we could use them as lesson length activities. We can use them as starter activities. We could use them as end activities. We can use them as homework, science club activities. There's endless possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 card tricks. It's crucial that you lay the columns out and share the cards in the columns like this. So we've got 3 columns and I'm sharing the cards out evenly. Don't build up 5 and then go on to the next one. You must share them out, okay? So, Sam, choose a card, keep in your head. I want to know what column is in. Column 1, column 2 or column 3?
Column 2.
Column 2. What I do is I pick up any one of the other columns, then I pick up column 2, put that on top, and then pick up column 3, or the other column, and put it on top. So in other words, your column that you chose is sandwiched in between the other 2.
I think I didn't really know that many card tricks. I think I'd done them myself as a child, but it was only when, you know, you were sort of reminded again of what they were like that you thought, oh yeah, that's how they're done. I want to know which column. Is it in number 1, number 2 or number 3?
Number 3.
Number 3. It's in this one, yeah?
We've got to do this 3 times. The repetition is quite good when you're demonstrating to the kids, because of course you've given them a chance to see it 3 times, so that's not a bad thing in itself. Where is it now?
Middle.
Now this particular trick, assuming I've done my job properly and you've done your job properly, which is tall order on my part at least, 1, 2, 3, 4, 5, 6, 7, 8.
Yes.
So the 8th card is always the answer card.
Your card, Seaway, is the King of Diamonds. Is that right?
I think it's important for everybody to remember that maths is not just about number. For example, visual spatially, with the positions of the cards within the pack, and really get the kids thinking, and particularly because it's appealing to this mystery and magic and they think, wow, how is that working?
Who can tell me something about the position of that card?
In the middle.
Wow, Aisha says that the card is in the middle.
Now you say, right, so this is interesting. So the answer card was the middle card. I wonder if there's other ways we could do this trick. Other numbers of cards we could use. So you say, we need to think then of a number which you can divide into 3 equal rows, and which is an odd number. And I'd write this on the board. I'd just think of the first 3, for example. I've got 9, 15, 21.
If we had 9 cards and 3 columns using your 9 times tables, how many cards are in each column? 9 cards. Good boy. 3.
So right, we now need to repeat the trick again to see if it still works according to the pattern that we think we've seen. The other thing I like about card tricks is once you've shown the children how to do the so-called trick, I know they're going to go and do that elsewhere. They're going to go home and show it to mum or dad or other friends and try the trick on them.
Is this your card?
Yep, that's it. Last thing I want to do. I want to do a bit of a dangerous experiment because we're going to do a rocket launching experiment. Right? First one. Here we go. See how many pumps I'm going to need. 1, 2, 3. Right, well that was a bit rubbish, wasn't it? Baby bottle went there. Mummy bottle, remember, is heavier. Got more space inside. We've got a bigger skin. So, I wonder whether that's going to make a difference to how far she can go. Hands up if you think she's not going to go as far. Hands up if you think she'll go about the same as the baby bottle. And bonk him on the head. Hands up if you think she'll go further than the baby bottle. Okay, let's see if you're right.
I like the tricks that Dr. Mark did because I really needed to use my brain before I answered the question correctly.
1, 2, 3, 4, 5, 6. This is interesting. This is fascinating. Look, baby bottle went to there. Now, mummy bottle is twice as big as baby bottle, and she's come about twice as far. So, daddy bottle is twice as big as mummy. So where do you think he's going to go? I've got a bad feeling about this.
Children can think beyond exercises they have to do in their books, but also feel a little bit different about maths and science, and it can be that exciting, it can be that interesting.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
This approach is to give children experience of using their own brain to figure things out. And higher order thinking is problem solving, communication, reasoning. So by coming up with ideas which will engage them, make them laugh, get them thinking, they will naturally engage those thinking skills, which are vital if we want these kids to progress. Did you enjoy your show? Yeah!
For explanations of these and other tricks, go to www.teachers.tv.